Yo. All right, so scientific notation. Let's change this problem up here. Let's call this a 6 instead. And Joey, pick a number.
Um, 5.3.
Okay, we'll go with 5.3 for this number. And La Katrina, change this number right here. -6. Okay, so we're going to make that a -6. We'll keep everything else the same, and that way you can try this on your own and do the weekly quiz. 6 times 10 to the third, that's going to be multiplied by 5.3 times 10 to the -6th. Yeah, so this is 6 times, let's just do the coefficients. 6 times 5.3. You know what I'm trying to get better at saying and You don't realize how often you say it until you're doing these videos and then you have to hear yourself speak. I have the worst voice. 31, that's 318. So 318. I think there's a decimal in there. 31 and 8 tenths. 6 times 5 is 30. So 31 and 8 tenths makes sense. And then for these, the shortcut that we learned back in the 1990s when we still had school inside of a formal schoolhouse and everything else, we learned that this is 3 plus -6, which is -3. The long cut for this would be, this is 1,000. This is 1 over, what would it be, 100,000? No, 1 over a million. This would be 1 over a million. That's the long cut, and we eventually were able to shorten it because we just knew, all right, you add the exponents here. So 31 and 8 tenths times 10 to the -3. We also said that in scientific notation, this number, which is called the coefficient, has to be between 1 and 10. The whole purpose of scientific notation is to take really small numbers or really big numbers and just write them into very ordinary numbers with a big exponent or small exponent at the end. So this would be 3 and 1800ths. If you were rounding, you could call it 3. It doesn't ask us to round though. 3 and 1800ths times 10. And because I just changed this number, I just divided this by 10. If I just divide this by 10, in equations we say whatever you do to one side, you have to do to the other side. But when we say that term side, we're meaning the side of the equal sign. Right here, I just divided this factor by 10. So since this is all on one side of the equal sign, it would be like, if I had, I'm going to use yellow, hopefully this comes in okay. If I had 6 times 8 equals 48, this is terrible. Yellow was the worst choice I've made of the whole day. 6 times 8 equals 48, divide the 6 by 2. If I still want this value to be 48, I don't divide 8 by 2 and say, oh, 3 times 4 is 48. I have to multiply 8 by 2. So if you divide a factor, you have to multiply the other factor to maintain its value. So because I just divided this by 10, I multiply this by 10. And if I multiply 10 to the -3rd by 10, think about that. I'm going to multiply this. Let me get out of this stupid yellow. Whose idea was that? 10 to the 1st. So I just multiplied 10 to the -3rd by 10 to the 1st. That's going to leave me with 10 to the -2nd. The temptation is to say, because I made this number right here smaller, I have to make -3 bigger, and you want to say -4, but -4 isn't bigger than -3. -2 is actually bigger. And this would be your final answer for the problem I made. But remember, your problem's a little bit different. Division, it's the same idea. Let's just change one number to make my life very, very simple. You know what? I'm going to keep the 5 there. I like the 5. Let's make this a -7. -7. How's that, Abby? That's good? All right. So 5 over 2.5. 5 over 2.5 would be like 2. You know who might be watching this is kids on the Kennedy team too. Ooh, the shudder at the thought. They don't have any right. 10 to the 4th over 10 to the -7th. So when you do this, it's division, right? 10 to the 4th over 10 to the 2nd. If it was just a positive over a positive, well, that's easy, right? 10 times 10 times 10 times 10 times 10 over 10 times 10. The 10s they'll get out of there, right? They'll cancel out. So you're left with 10 to the 2nd. But if we have a negative here, it's, how I subtracted the exponents here to get 2? I have to subtract these. So it's 4 minus a -7. And 4 minus a -7, hopefully we recognize that this will actually make this 11. So 5 divided by 2.5 is 2 times 10 to the 11th would actually be the case there. So hopefully that helps you with these ones here. Remember with these are both negative exponents and you're multiplying. So think about what we did when we multiplied up here with 3 and -6 with the exponents, okay?